Thank you, Evan Moglen, for one of the most thought-provoking speeches I've heard. So my name is Kai Arne. I'm MySQL's Vice President of Community Relations, and I am your referee. So I will be introducing 7 egos, one for each bar stool here, database egos, one at a time. And then I will provoke a fight between them. So I don't want to set your expectations too high, but I might also have to pull them apart. And for that purpose, if they don't fight according to the rules of the game, I will blow the whistle. I will now do a beta test of it. I will step away from the microphone. I might have to do that and give them a penalty, and the penalties I can give them because of things like marketing fluff, for mumbling, for excessive pontification, being too big egos, or for avoiding the question. So let us have our first ego, who is none other than the father and co-founder of MySQL, Mikael Monty Virenis. God morgon, Monty.
God morgon.
So back in the 80s, both you and I had our own companies, and we were working, and we had customers. And one thing that connected us was that we both used databases. One thing that set us apart was that you were writing some kind of ISAM routines yourself, and I was using a real database. So why did you do that?
To solve the needs that I had, and the commercial databases at that point in time didn't fit my needs.
But isn't sort of a bit exaggerated to write your own routines because of that reason?
I think that back then there wasn't any open source database I could use that was suitable. So I had to start writing my own.
So you're now already fast forwarding to when you were writing MySQL. First, to begin with, you were just writing some ISAM routines. And then at some point in time, you decided on top of ISAM to write an SQL layer. Now, why was that?
The old database was used for data warehousing, and we had lots of customers for it. And as the world evolved, internet started to rise its nice head, so to speak. And we needed a way to get the data out to the customers. And SQL seemed to be a suitable way for embedding things easily with the browser. So I wrote the SQL on top of my old code to be able to access it more easily.
To me, it still seems like an exaggerated solution. Did you write your own text editor as well?
Actually, I did. But that was before I switched to Unix and found the best text editor in the world. Emacs.
So I think we should go back to databases and your database. So why did you go open source with it?
I did go open source.
Yeah, why?
Why? Because when I did write MySQL, I couldn't have done it without the open source tool that existed. GCC, Emacs, and other stuff. And during the years of using these, I and David always wanted to be able to give something back to the community. Before we had MySQL, we had lots of tools, but they were very specialized. So they were not really suitable for large distribution. MySQL was the first thing that we thought that there may be somebody who could have a little use of it.
Thank you, Monty. So, our next ego shares your native country, your stubbornness, and yes, several databases, including Solid, and is most known as the father of the InnoDB storage engine. Heikki Tuuri. Huomenta, Heikki.
Huomenta, huomenta.
So for those of you who didn't know that tune, it was the first popular ringtune in Finland for the Nokia phones. And that's a good characteristic, I think, for you. So, Heikki, I'll ask you a similar question that I asked Monty. What made you want to write your own database?
I wanted to make the world's best and the fastest database.
You now say what you wanted to do, but what's the reason for creating an own database?
Okay, now I see it. It is that stubbornness.
Okay. So, being stubborn, how did you get started?
I worked for Solid and then I went to university and I looked through the whole library about databases.
Okay. And then you wrote Begin and then you went open source? Or how did it go?
I started writing InnoDB after I left university in 1995 and it was not my intention to make it an open source because open source was not that well known at the time. But when I met Monty in August 2000, Monty said that I should make it open source.
And you obeyed?
Yes.
Okay.
I have to give credit to his good
Judgment. So, Heikki is interfacing to MySQL through what is known as the Storage Engine API. Why did you write that one, Monty? How did you have Heikki integrate with you?
The story of that one is, to make it short, that the old product did work first with a commercial kind of ISAN thing, and then I wrote my own, and I wanted to make it easy to have access to both within the same product. So in about 86, my old product, Unireg, could work with different engines, and the only way to do that efficiently was to have an API.
I think we'll have to come back to that API, but let's first go for some more egos here and scroll forward to the year of 2003 and look at the database MySQL cluster. So this database was not the fruit of one single individual ego, but of a team in a large company, Ericsson. And within this team there was at least one big ego, though. This person is the father of 5 children and the architect of MySQL cluster, Mikael Runström. Good morning, Mikael.
Good morning.
So, you didn't hear all of the tune. It was supposed to be The Winner Takes It All. It's a competitive song from the native country of Mikael Runström. That's, I think you should soon start to get a bit more aggressive. The audience has paid for seeing a fight here, okay?
Okay, yeah, it's maybe not my nature, but
first
competition is my nature, so make it a competition that will be very aggressive.
So first I have a question related to the third normal form. Now, we have prefixed you all with 2 initials here, in the case of Heikki with 3. That's because the creators of the databases, the writers of the initial theoretical background, E.F. Codd and C.J. Date did so. And for you it's U.M. Runström, and I hear that U.M. means Ulf Mikael, but that's Monty's first names as well. So does this mean that a first name is not a good choice for a key?
Obviously not, and not even if you add the birth year, it wouldn't even, we were born the same year, so not even that would help.
Okay, so, but getting back to databases, seriously, you were an entrepreneurial ego in a large company. How did that feel?
Well, it's Ericsson was a very technical company and had lots of entrepreneurs, but I had a lot of sort of vision of what I wanted to do, and just kept, I guess I was a bit stubborn as well. At least I'm even accused of that sometimes.
And how did your stubbornness react to the storage engine API?
Well, the first thing is actually pretty good because I never wanted to write an SQL engine. So I was very happy to see that I could get rid of that problem by implementing the storage engine API instead.
Okay. So Monty, Heikki and Mikael, you're all far more polite than I had expected and far more polite than necessary. We need somebody who can disagree with you on stage. Let me introduce to you the father of I don't know how many databases, and now the Falcon storage engine, Jim Starkey. Good morning, Jim.
Good morning, hi.
So, this is the first time I greet somebody in English. I've greeted people in Swedish, in Finnish, and then Swedish again. Does the United States still have anything to say in the future of databases?
Well, gosh, when you Scandinavians needed some new technology, where'd you come? We do transactions. I'll explain that to you later.
So, well, you created something like 4 databases around that figure, or what?
5? I don't know.
You had a food table scan there, I see.
No, let's say I'm a little older than these gentlemen.
So now you must guess the following question coming up. What's the difference now? What different considerations do you have to take when you're creating this database? What's different now that influences the architecture?
Oh, it does transactions, it does blobs, it does all sorts of nice things. It uses memory different, it uses threads differently. We're bordering on marketing fluff, blow your whistle. I'm repeating myself.
I was more thinking about what has changed in the marketplace. What has changed in technology, rather than what are the cool, nifty little features, marketing fluff that you're saying here.
Oh, the marketplace is wonderfully different. Back in the old days, we had big computers and small people, and I've got big people and little computers, but they're all connected across the world. And I think the primary challenge we have in the database world is building database systems that are friendly to the web. Rather than teaching the web to use punch cards, we should have databases deal with the web.
Okay. So before introducing more egos here, let's have the 4 first egos battle a bit.
Yeah, my first question to Jim is obviously, why do you need to write 5 databases? Why don't you do it right the first time?
Glad you asked that question. As a budding entrepreneur, let me give you the answer. You sell them and start over.
So
Starting over is important because you learn new tricks. And if you get rid of the old stuff, then you have to start over. The only downside is that you have to keep writing string-to-date conversion functions.
I was just going to blow the whistle for financial fluff, but I'll return to technology. I hear amongst the 4 of you, you Jim, keep telling me that you're the biggest fan of the storage engine API.
Oh, yes, the storage engine API. I've been thinking about this because I thought it might come up. And I have an analogy about what an API is. Now, suppose you had a TV set and you went out to buy a DVD player. Now we have an interface here. You open the DVD box and you have what's called an instruction manual. And it says, take the cables, find the part of the TV that says AV1, match the connectors to sockets of the same color and shape, and then watch your DVD. And that's what an interface is. Now, your TV's got your S-video for backward compatibility, your component video for current, and an HDMI for point. So you have an interface that does forward and backwards compatibility, and that's a good thing. Now, we take the MySQL server, and we're going to do the same thing, except now we open up the whole back door, and we look at a bunch of wires and components, and then you pull out the piece of paper, and it doesn't say instruction manual, it says marketing statement. And I said, okay, what you do is in your right hand, you grab the bundle of wires, you stick it in elbow deep into the box, and connect them as appropriate.
Try that.
I believe very strongly in the storage handler interface. I believe it's a great message. I think it's a great way to introduce new technology for people who don't know how to write a SQL parser.
I detect a slight mismatch between the last two statements of yours.
But we got to make it simple. We got to make it stable. We got to make it easy to use.
So Monty, do you have anything to say in your defense?
I think Tim is right. But he's a little bit misguided.
So Monty, you yourself are working on an enhancement to my ISM new storage engine. What kind of changes would you want to see happening in the storage engine API?
Actually, I run transactions because the first storage engines, they didn't have transactions. And in that regard, the interface is more than crude. We need to clean that up. And there's a lot of things that has changed during the 12 years that the API has existed. And the nicest thing that I can say about the API, there's really few API that can work for many vendors and for many years. So it has potential to be even greater.
Heikki, is it great?
No. It's very, very complex.
Mikael, what's your opinion on this one?
Well, I mean, it's some people say it's 1 week to get something, and it's probably 1 week and you have something going. But let's face it, it's a 3-year trial and error period to get something really working. And obviously, you can make that simpler. But and it's also pretty interesting. I'm doing a clustered engine, and obviously we have transactional engines, we have clustered engines, we have non-transactional engines. And there are a lot of things the clustered engine can do that the non-transaction engine can't do, and vice versa. So you simply can't sort of mix them completely.
So you say you can figure it out in only a year and a half? Wow. I only have 2 months to go.
So can you mix and match, Monty?
Engines.
Yes.
We are doing it. And we need to be able to do even more mix and matching in the future. Because there are engines that are going leap ahead of what we are doing now and crossing new bridges. And we need to have an API that is ready for it. So we need to modernize it. That's kind of just obvious. The question just how, what's the best. And that's why we need guys with the expertise that we have here that can help us do that.
Transactions, I think, Jim, you're the one that is most aggressive when it comes to claiming that everything is fully ACID. Are you fully ACID?
Am I what?
Fully ACID compliant?
I'm absolutely ACID compliant.
And can you
I'm not even from the 60s.
Don't you see
I don't even know what that means.
Can you take it back up?
Don't you see any gray zones here? Can we be sort of halfway ACID, a bit little a bit less acid, like lowercase d or something in acid, and then
Well,
you get some more performance.
actually, if you're on Windows, it's any case, and it's case insensitive, but if you're talking about running on Unix, well, then it's case sensitive. And if you're talking about working on the Macintosh, well, that's more complicated because it depends which file system you're using. Or, so if you do change the table, the rules will change.
I will blow the whistle for confusion here.
That's what I'm talking about, is confusion.
That's the C in acid, or?
So Heikki, do you see a gray zone here? Can we sort of make InnoDB a little less acid and get something for it?
Yes, we are relaxing this gap blocking, as I explained in my talk yesterday, and that will also reduce deadlocks. But I disagree a bit with Jim about the acidity of an outcome, because I'm afraid it doesn't support the mathematical serializability.
Jim?
I couldn't hear what he was saying.
Okay, so you said the mathematical durability part of it.
Serializability.
Serializability, sorry.
Oh, serializable. Well, acid is not serializable. That's a problem.
That's a locking mechanism, and that's not really.
No, acid is let's see, we did this talk yesterday, Ann. Atomic, and Falcon is atomic, and it's consistent. It provides a consistent view of the database. You don't see phantoms. You don't see records that haven't been stored yet. It's isolation. You don't see other transactions that haven't been committed. And it's durable. It's durable as long as your disk works.
Isolation is serializability.
No, isolation is serializability. You don't see other transactions. No, I'm arguing against serializability. I think that's a fine thing. And we all know how to do serialized database. That's the easy database. You just run one transaction at a time, and it works. It does have some drawbacks.
So Monty, you don't ask for the word if you're a clash of a DB, because you just go ahead and shout.
Just go back a little bit in time and say, when I started writing my SQL, I was more concerned in making a stable database that doesn't crash than have a database that crashes the whole time. You need to recover transactions to keep it up.
Okay, I think it's time to have more egos here on stage. Our next ego is the architect and CTO of Solid, Ari Valtanen.
Welcome. Thank you. May I contribute to your fund?
Follow this man's example.
Great.
Huomenta, Ari.
God morgon, hyvää huomenta.
So we're back greeting in non-English now again, are we?
Yes.
So that was a preemptive answer. You're an established database player with Solid. What made you want to provide your database as a storage engine in MySQL?
Well, to be honest and frank and answer to your question directly, in fall 2005, Morten was very persuasive and convincing we should do this.
And he succeeded just like...
Yeah, I think he was right, and I'm glad he did that.
So, bearing in mind the risk of marketing fluff and whistleblowing, who should be interested in your database?
Anybody who's interested in transactions and durability, high availability also. It's a transactional engine, and I believe in the same things that Heikki and Jim are advocating here. Acid.
But I thought MySQL Class was the answer to those questions.
Not all of them. Definitely not
We are
all of
not
them.
advocating God.
Sorry?
We are not advocating God.
Thank you for making that clear.
Thank you.
For a moment I was not sure about that.
Let's have our following ego up on stage. He's the father of the Nitro storage engine, Paul Whittington.
Oh,
Just to be different.
I don't have $1. I haven't sold yet. That's
So morning, Paul.
Good morning.
Let's first ask, what is the Nitro storage engine all about? Or what's the Nitro database all about?
The Nitro database is all about really high speeds, really large volumes, and really fast queries.
And how do you make these queries really fast? And I understand from having talked to you that really fast means faster than my eyes. And is that possible, Monty?
All the different storage engines can do things faster in some way, and there's not a perfect solution. And by just combining different technology, you can do things faster. And that's why we need the storage engine API.
Let's give Paul the word. You do something, you do some magic with indices. I hear that's how you can report.
Yeah, that's right. We're able to do what we call positional awareness. So any index entry knows where it is in the index. And that turns out to be very useful. And we also can do things called aggregates. So at any point in an index, you can know the sum of any field in the record at that point in the index. And by doing so, we can do very large analytical queries, averages, standard deviations, sums of various kinds, in basically 2 index reads for any piece of the index.
So what this means is that you have more stuff in the index, you have the averages and the sums there, and that's something that distinguishes you from the rest.
That's right.
Doesn't that mean that the DBA has to know the questions in advance?
Yes.
He would
Good
give us the
point,
questions in advance.
Yeah, no kidding. You guys ought to try this. You think that's fun, right? Yes, you're right. You're absolutely right. And we have found in our work and what our customers need, they have predictable query loads. They know the kinds of questions they're going to ask, but they have extremely high insert rates and hundreds of millions of records, and they need the answer right now because my network's down. Or I want to know how to maximize the profitability on a flight coming into O'Hare in a snowstorm against the wind. Yeah.
So against the wind, what made you want to provide your database as a storage engine with MySQL?
Well, we have a security product line as well, and as we've been selling that product line, customers keep saying, hey, can I use your database to do what you're doing? And we said, well, you can, I suppose. And as we looked at how to offer that to them in a way that they could use it, MySQL was the perfect fit. Because they already mostly know MySQL. We can plug a storage engine down underneath, and they can mix and match it with Cluster or Inno or Falcon and do transactional and non-transactional work at the same time. So that's how we ended up here.
Thank you, Paul. Let's now go for our final ego. There's a bit of a longer introduction here. You may have read my blog that I had hoped for the real big DB egos, those who created the database industry, EFCOD and CJ to be here with us. Neither could come. So EFCOD passed away a few years ago, and CJ had some other excuse. But indicated to J Pipes that he might be available next year. So instead, I have the pleasure to introduce Mike Smith from IBM. So I think most people in the audience have heard about your company. And
Or work for it.
And some of them are even aware that you as a company are somehow involved in databases, right?
We have a database, that's true.
So I suppose you come up here to tell the world that you're now providing DB2 as a storage engine, or what?
Actually, what we are here to talk about today is to provide a storage engine for a specific product in the IBM family. As Monty had stated, we have a product, it used to be called AS400, was iSeries, is now System I. that was developed the same way that Monty had started. We had a relational database role-oriented, and we eventually put an SQL layer on top of it. The difference that we had, as opposed to what Monty did, is we also had an operating system and a hardware, and we very deeply integrated those together such that virtually all of the data that's stored in our mid-range systems is in the DB2 storage engine that's part of the System I today. What we're looking at doing as the storage engine is to make that data available to all the MySQL applications. So we'll be able to open up all that data by providing the DB2 storage engine for System I against all the MySQL applications. On the flip side, we also have a lot of applications that are written to that DB2 storage engine as well. And by providing a storage engine for MySQL, we'll be able to store that data into DB2 and all those other existing applications will work. So it's about opening up new applications to old data and old applications to new data.
I think you answered my two following questions as well with that.
Yes.
SQL Server.
What did you say?
Where is Microsoft SQL Server?
Microsoft SQL Server, there's no more chairs here.
It crashed on the way here.
So, of the audience here, not everybody is on I5. What do you think the significance for this particular audience is of the announcement that MySQL and IBM has made today?
The significance of the announcement today is there is a huge customer base that's now available to MySQL applications that we can seamlessly grab and make available to this community instead of doing rewriting and reporting of applications to i5OS.
Can I paraphrase?
Of course.
You can't beat them, join them.
So we now have all egos in place. Let's warm up by a simple, non-provocative question open for anybody on stage. How should a smart developer select a storage engine? So he just select Falcon or DB2, etc.
Smart developer downloads a C++ compiler and starts coding. The lazy developer who wants to get the job done, well, that's a different question.
Well, that's the question I'm asking.
A lazy developer who doesn't want to code it himself or doesn't want to wait, they can as well go to our website and download it.
And I think they ought to just look at the matrix that MySQL has of all the engines and what they do best. That's what I do.
Or look at where your data already is and make sure that it interoperates.
Some of this stuff is futureware that we're talking about here.
So look at this straight. Everybody up here has written a storage engine, and we're all saying, don't do it.
I didn't get asked that question. It's a good thing they have professional services.
I want to warn anybody who is imagining writing a storage engine for this storage engine API. It's amazingly simple. It looks so easy that you can almost get it going in a week. You can. But the usual 80-20 or even 90-10 rules apply very well there. So the integration optimization phase can take some time.
Yeah, it's kind of like hitting golf balls on the range and playing with Tiger Woods. It's really tough.
Putting is the key there.
It must be that the hole is too small.
I'm glad you bring this up, because I need analogies. I have this conversation with Martin every 2 weeks. About how long it takes.
So Monty, you've been awfully quiet. How do you think one should go about? I mean, smart developers. This room is full of smart developers and DBAs. How should they go about identifying the right engine for their purpose?
That depends totally on the application. And the question is, are they bound by space or speed? And that's kind of the first question. And do you need transactions or not for the benefits of that both of the for the needs? And there's not a single answer. But the thing is that what you first need, you need a available and a stable engine. And that's what we need to use first. And there's lots of us that have that somewhere there still on the way. I don't know how stable DB2 is under my scale.
So obviously the smart developer has to know all these storage engines. That's the first thing the smart developer does have to do. And the smart developer also knows that those engines are actually open source. So if they don't do exactly what he wants them to do, then he goes to BI.
I'm going to disagree with the other opinions. This is unusual for me. The smart developer doesn't have to get it right the first time. He can pick one at random, develop his application, then move it around until it runs best. And if a new one shows up, he can move it again. I mean, that is one of the nice things about the architecture. So alter table, change engine.
Unfortunately, not all the engines are equal, although the API is the same.
You're broad.
I wish I don't.
I have a question to IBM. Is DB2 going to be open source?
I don't think you want it. The DB2 that is embedded in System I has gone through at least as many years of development, and I don't think you want to see it. We do plan on open sourcing the integration layer, if you will, that's going to map from the storage engine API to the top of the record-oriented interface that's inside of System I. But the rest of it, there's actually hardware accelerators for the storage engine that I'll let you do with in the open source.
So, getting to be a bit more philosophical, let's fast forward from today 20 years ahead in time, and let's open up Wikipedia, and you're all egos, you'll look for your own entry. What do you want to be remembered for 20 years from now?
If I can use my ego and a little bit change the question. The thing is what I wouldn't like to see in the entry. And there's kind of two things. Monty, author of MySQL, deceased. And the author of their no extinct MySQL server. But I don't
I'll blow the whistle for avoiding the question.
I expect that we have a glorious future. The problem is that I couldn't envision this to happen 10 years ago. We started getting out MySQL that we're doing something good, giving something back, and maybe we can get a couple of consulting gigs on the way. So I don't expect to be able to predict the future. I just see that I hope that I will see the path for the next year, and the path will continue.
What do the rest of you guys want to be remembered for?
Well, as you know, Wikipedia runs on InnoDB.
So you would want that to be the case 20 years from now too?
Yes.
Well, obviously to be remembered for being a good father to both your children and your grandchildren. And hopefully also to have the first open source database with $1 billion business.
Yes.
Hopefully I already have a footnote for the blob at NBCC, but what I'd really like to be known for is the person who convinced the world's largest, most important, best open source database that they have to recognize the semantics of the web and learn from the last 10 years of internet experience and learn to do multi-column, multi-table search, to have a security model that works for the internet, and lots of other good things. Oh yes, and to have a data type that says, this is a string, don't worry how long it is, so we don't have to count how many characters in everybody's last name.
In other words, you want us to break the SQL standard and invent our own.
Oh yeah.
But Monty, that's what you did.
And we always argue that if something doesn't work in MySQL, it's bad because it breaks the standard. And I know that he doesn't care about the standard. Things will be easier in the future.
No, I think boring things should be standard compliant.
Okay, continuing the Wikipedia round. Actually, I went to Wikipedia one night and I was amazed by finding a list of Swedish-speaking Finns. There is a list of that. Monty was on the list. Congratulations. I didn't find Morten on the list.
I think he is there.
Sorry?
I think he is there.
He was not on the list that night.
Well, by now he is.
Actually, I wish there was a list of Finnish-speaking Finns. There wasn't. If there is a list, I would like to be on that list.
That was a complete answer. Okay. Oh.
I would like to be recognized as being part of a team that changed what people thought you could do with a relational database. We literally hear all the time, you can't do what we need to do with a relational database. But I say you can. And I'll prove it to you.
I think we're proof of that. Right? Everything we've done has a relational database underneath it. It's embedded into the operating system. Even our TCP/IP configuration is stored in the database. You can do anything with a relational database that has good MSD properties. My Wikipedia entry, probably something about my senior PGA career.
After we sell our company. Well, I don't know how you're going to pull it. I'll just, 10% goes to you.
Yeah.
So as a referee, I will have to blow the whistle now and say that the match is over. I won't appoint a winner amongst you guys. The only winner I think that can be appointed is the user. The user can choose the storage engine that fits the purpose of his application. And having more engines for special purposes, like the last 3 guys have been introduced here, is good. So with all of this, I would like all of you guys, except Monty, to leave the stage and continue your fight offline. Monty will join you later.